Okay, here is a question of physical chemistry, and we need to calculate. We need to know whether precipitation will take place in this reaction or not. So this is the question. We're told in a reaction, in a precipitation reaction, a student took 200 ml of 0.2 molar sodium hydroxide and added exactly 1000 ml of 0.1 molar calcium chloride. Determine whether precipitation will occur, and we are given the KSP, solubility product, 8.0 times 10 raised to negative 6. So for us to know whether precipitation will take place or not, we need to compare the KSP and the reaction quotient. So if the reaction quotient, that is Q, is less than the KSP, that means there is no precipitation that is taking place. And if the reaction quotient Q is greater than KSP, that means there is precipitation that is occurring. So first we need to get the reaction quotient of this reaction. So let us first write our ionic equation in this reaction. So our equation here we are given, we have got sodium hydroxide plus calcium chloride forming a calcium hydroxide and what? And sodium chloride. So our ionic equation is calcium ion plus hydroxide ion forms calcium hydroxide. So that is our ionic equation. So we need to get the concentration of calcium ion and the concentration of sodium hydroxide. Hydroxide ion. So to get that, in our question we are given, in the reaction we are told 200 ml of 0.2 molar sodium hydroxide and added exactly 1000 ml of 0.1 molar calcium chloride. So that means to get the concentration, the final concentration of calcium ion and the final concentration of hydroxide ion, we need to use this formula, that is M1, that is the initial concentration, times the final concentration, is equal to the final concentration times the final volume. So for the case of calcium ion, here we have got 100 ml of 0.1 molar calcium hydroxide, calcium chloride I mean. So our M1, to get MF, that is the final concentration, we need to divide our final volume on this side, final volume on that side. So that means MF, that is the final concentration, is equal to M1 V1 all over VF, that is the final concentration. So the initial concentration of calcium ion is 0.1 times the initial volume of calcium ion, that is 1000 ml. So that one we need to change to liter, we divide with 1000 all over final volume. So the final volume, you add the two volume, that is 1000 plus 200 ml, that is 1200. Since it is ml, we change to liters. So that will be 0.1 times 1000 over 1000 is just 1 all over 1200 all over 1000, that is 1.2. So that will give us 0.1 times 1, which is 0.1, divide 1.2. That is 0.0833. So this will give us 0.0833 is the concentration, the final concentration of calcium ion. So again, we need to get the final concentration of hydroxyl ion. So this will be equal to, we still use the same formula, M1 times V1 is equal to final concentration times final volume. So the final concentration will be M1 times V1 all over the final volume. So in our case there, the initial concentration of sodium hydroxide is 0.2 times the initial volume is 200. Divide that one with 1000 because you change to liters all over the final volume, which is 1200. You still change that one to liters. So that will give us 0.2 times 0.2, which that is 200 over 1000 will give us 0.2 all over 1.2. So that is 0.2 times 0.2. Divide that with 1.2. So that will give us 0.04 all over 1.2, which is 0.033 is the final concentration of sodium hydroxide. So since the coefficient of sodium hydroxide is 2, this one we square. We square. Okay, so from there, to get now the reaction quotient Q is equal to the concentration of calcium ion times the concentration of hydroxyl ion. That one we square because the coefficient there is 2. So that is equal to the concentration of calcium ion is 0.0833 times 0.033 square that. So that will give us so that is equal to, let us multiply that. Let's square first. 0.0333 square is equal to, so this is equal to, let's change this one, write in the standard form, that one is 8.33 times 10 power negative 2 times 1.12 times 10 to the power negative 3. So let's multiply that. So that will be 8.33 times 1.12. So that is equal to 9.33 times 10 raised power negative 5. So this is our reaction quotient. So we compare now the reaction quotient and the solubility product. So that means if we look at our solubility product is 8.0 times 10 power negative 6, and our reaction quotient is 9.33 times 10 power negative 5, which means our reaction quotient is greater than the KSB. So that means Q is greater than KSP, and that will tell us that there is precipitation that occur. Precipitate will form in this reaction because the Q is greater than the KSP. So that is how to know whether there is precipitation taking place in a certain reaction or not.